p139, 140, we're starting to take a look at when we look at not one individual bond, but all the bonds within a molecule and what is the resulting shape of the entire molecule. In the shape of the entire molecule, all the atoms and how they bond and the bonds are placed around a center atom is what we refer to as molecule polarity. So molecule polarity, this is the shape of the molecule. So take a look here. There are things within a Lewis dot diagram that help us determine the overall geometry or shape of a molecule. So take a look. We have the molecule ammonia. Nitrogen has this electron pair that it keeps for itself. So these would be referred to as a non-bonding electron pair. So non-bonding electrons. Whereas the electrons sandwiched between the nitrogen and the hydrogen, they are used to form a bond. So this is an example of a bonding electron pair. And what happens is what happens to the electron cloud, those orbitals, whether they're trapped in a bond or allowed free, it determines how much they're allowed to spread out. So electrons that are used to share a bond, they are held and they're not allowed to spread out or take up as much room because they're trapped between these two positive nuclei that control them. Whereas a non-bonding electron pair, it is only kept in check by a single nucleus, and so it's allowed to balloon out. So we have to take into consideration electron to electron repulsion. So when you bring two electrons near each other, they don't attract, they push apart from each other. They move apart. Well, when you think about it, if you have one side has one electron versus another side is an electron pair, the electron pair, double negative power, has a greater ability to push compared to a single electron. So the pushing apart is to a greater extent. So if I was to draw some dot diagrams or what you might see, so like oxygen. So when we draw oxygen, we see that oxygen as an atom has two electron pairs plus two unpaired electrons. So the repulsion between this electron pair and this electron pair, it's pretty equal because it's two electrons. But here we have an electron pair pushing on an unpaired electron. Double negative can push harder and compress this. So this pair of electrons takes up a huge room, and this other pair takes up the same amount of room. But these unpaired electrons, they don't have as much repulsion around. So they take up less of the cloud area around. And this helps us dictate the shapes. So here we go. We have a rule that's called the honk rule, and it is based on the center atom. The center atom typically has the lower electronegativity, and it tends to form the most bonds. So here we go. H could stand for hydrogen or halogen. So if it's hydrogen, here is its dot diagram, versus if it's a halogen, top guy member is fluorine. What these have in common is the number of unpaired electrons. Remember, unpaired electrons are the only ones used to form bonds. So this unpaired electron in hydrogen needs a partner. It's going to get it through bonding. This single unpaired electron in this halogen fluorine is what's used to form a bond. So Hydrogen and halogens, they have one unpaired electron. Therefore, these types of atoms, they are only allowed and must form one bond. And because they can only form one bond, there's really only one shape that results. So if we have a diatomic molecule, we could have hydrogen bonded to another hydrogen. We could have a hydrogen bonded to another type of nonmetal. We could have fluorine bonded to a second fluorine, or a fluorine bonded to another type of atom. So the dashed line represents the bond. Non-bonding electron pairs are left around the outside. And so the angle that's created between the two nuclei in this type of structure, the shape is linear. Okay? So now, oxygen. Oxygen hails from group 16. And all the members of group 16, like oxygen, they have 6 valence electrons. So when we draw the dot diagram, electron 1, 2, 3, 4, 5, 6. So take a look. Oxygen's dot diagram, it has 2 unpaired electrons. So therefore, it needs every oxygen or every group 16 member, when it's put in a molecule, it has to form 2 bonds. So the oxygen, it doesn't form one bond, it doesn't form 3 bonds, it forms 2 bonds. So there's a little bit of a trend here. So because the oxygen has to form 2 bonds, there are 2 methods in which it can do it. So first method is that the oxygen, it forms 2 single covalent bonds. And so this would be known as bent. The second option that a group 16 element like oxygen has is, instead of forming 2 individual single covalent bonds, it can form what looks like an equal sign and form a double bond, and then the shape would be linear. Okay? Moving on. In honk, the N stands for nitrogen. Nitrogen is the top member of group 15. So, like every member, nitrogen and all other group 15 members, they have 5 valence electrons. So when we draw nitrogen's dot diagram, electron 1, 2, 3, 4, 5. And when we take a look at it, group 15 members like nitrogen, they have 3 unpaired electrons, each one looking for a partner. So a group 15 member like nitrogen has to form 3 bonds. So there's a pattern here. Since it has to form 3 bonds, there are 3 different ways this can be achieved. So first possibility is where the nitrogen, it forms 3 individual single covalent bonds, and this is what we refer to as pyramidal. Number 2, the nitrogen, instead of forming 3 individual single bonds, it could form a double bond and a single bond, where this would create a bent shape. And the last possibility, number 3, is where the nitrogen forms the 3 bonds between itself and one other atom, creating a triple bond, and this would simply be a linear shape. The last letter in honk is C, stands for carbon. Carbon is the top member in group 14. So carbon, like all other group 14ers, they have 4 valence electrons, And when we draw this, we always draw it in that hybrid where we place those one on each side to maximize the bonding. So it only ever uses the hybrid. So group 14ers, when they go to bond, they have 4 unpaired electrons. So group 14 members, they have to form 4 bonds. Well, following the trend, there are 4 ways that this can be achieved. So first method would be the group 14er forms 4 single bonds. And when we see 4 individual single bonds, we call this tetrahedral. Number 2, the group 14er, it could form a double bond, 1 double bond, and then 2 singles, and this is trigonal planar. The third way it could achieve its 4 bond need is forming 2 double bonds, and then the shape would be considered linear. And then the last possibility, number 4, would be it forms 1 triple and 1 single, but it would still be linear. So these are our ideas of how we're going to predict the shape. We're going to first pick out the center atom, typically has the lower electronegativity, and it tends to form the most bonds. And then we'll figure out how to work through the others.